So now that we've gone through and did a couple examples of analyzing diagrams and reading about ionic attractions, we're going to predict formulas of ionic compounds. And we're not going to draw Bohr models every time because that's a lot of work. So we can focus on just the valence electrons, and the tool that we have for that are Lewis dot structures. So one thing to remember is that we have a cation, which are positive ions, anions, which are negative, and the octet rule. Those are the big things to remember. So octet meaning 8. So remember that the electrons want to get to the magic number 8 for each atom, so that way it can have a complete electron orbital, okay? And when we're talking about these beginning ionic compounds, we're going to be looking at a metal combining with a non-metal. All right, so let's go ahead and start with the first one. So it says dot structures, ions formed with charges, and then formula. So for the dot structure for sodium and chlorine, I'm going to draw them individually first. So sodium is Na. It has one valence electron, so it has one dot representing that valence electron. Chlorine is in group 7A, so it has 7 valence electrons. So I'm going to draw my dot structure. So if I look, sodium has 1 to give away, and chlorine needs 1. So this 1 from sodium will transfer to chlorine. And the reason why metals give up their electrons is because it's much, much easier for them to lose 1 or 2 or 3 electrons than to try to gain 5, 6, or 7 electrons. So they'll lose them to lose that outermost energy level that we saw in the diagrams before, where your nonmetals already have 5, 6, or 7 valence electrons. So they just need to gain a couple more. So then they'll become negative and gain those electrons. So now let's see if everyone's happy. Well, sodium gave away its electron and chlorine now has 8. So ions formed with charges. So now sodium is a plus charge, and we don't write the 1, we just write a plus, because the fact that we wrote the plus means that it has at least 1, okay? And chlorine now has all 8 of its valence electrons filled in with that 1 coming from sodium. And this entire atom has a negative 1 charge. And again, we don't write the 1. The fact that we wrote the minus sign means that it has a 1 negative charge. So when I write this out actually as a formula, I'm writing what do they look like when they're stuck together. So we write our metal first and then the non-metal. And we write them right next to each other, no spaces, no commas. So I have 1 sodium next to 1 chlorine, NaCl. Okay, let's look at the next one, sodium and sulfur. So I'm going to start at the beginning and draw the dot structures. Sodium is Na with 1 dot. Sulfur is in group 6A. So it has 6 valence electrons. Now sodium has 1 to give, but sulfur needs 2 more to get to 8. So sodium will give up its first electron to sulfur, but sulfur is not happy. And the only 2 elements we have to work with are sodium and sulfur. So what I can do is add another atom of sodium. This is just like that third example with its 1 valence electron that can be given to sulfur. So now sulfur has 8, and 2 sodium atoms are both happy because they got rid of that 1 extra electron. So ions formed with charges. I have sodium plus and sodium plus. Okay, now it's really important that you write that twice because there's a difference between writing 2 sodium Na pluses and an Na2 plus. What this means is that 1 sodium atom lost 2 electrons, but that's not what happened. We had 2 atoms of sodium each losing 1, okay? So that's why we write this twice. This is incorrect. We have 2 sodium atoms and each one gave 1 electron away. Our sulfur then has a complete shell with 8, and this entire sulfur now has a 2 minus charge, and it's 2 minus because it gained 2 electrons. One thing to point out, that when we're writing our pluses and our minuses, we write whatever the number is, so 2 plus or 2 minus, we write this number first and then the symbol, okay? And that's because if we write it the other way, like a +2 or a -2, these are oxidation numbers, and we don't want to use those. We want them to be known for charges, so you always write the number and then the sign. So if I write this as a formula, okay, I have 1, 2 NAs and 1 sulfide ion. So I'm going to say Na, because that's my middle, and I have 1, 2 of them. So I'm going to add a 2 as a subscript, indicating that I have 2 sodium ions and sulfur, Na2S. All squished together, no spaces, no commas. Now let's look at magnesium and chlorine. All right, well, magnesium is in group 2A, so it has 2 valence electrons. So that means it's going to be looking to give away both of those electrons. Chlorine is in group 7A, so it has 7 valence electrons, which means it's looking to gain just 1 more to get to 8. So magnesium is going to give away one of its electrons to chlorine. So now chlorine is happy, awesome. But magnesium is not. There's still 1 more electron that needs to find its way to a chlorine. So because I'm only working with magnesium and chlorine in this problem, I'm going to add another chlorine atom. Okay, and this chlorine atom, just like every chlorine atom, needs 1 more to get to 8. So the magnesium can transfer its other electron to chlorine. Now double check and make sure everyone's happy. Magnesium gave away its 2 electrons, and each chlorine atom now has 8. So ions formed with charges. Magnesium, 2 plus, and it's 2 plus because it gave away 2 electrons. And we remember we do 2 plus, not +2. That means something else. And then there are 2 chlorine atoms, so I'm going to draw 2 chlorine atoms, and each chlorine atom has a -1 charge because each chlorine gained 1 electron from magnesium. Okay, so Mg2 plus and then a Cl minus and a Cl minus, and if I write this as my formula, I have 1 Mg. And we don't write a subscript of 1 or anything down here because the fact that we wrote Mg means that we have at least 1 of them. And then chlorine, Cl, and there are 1, 2 of them. MgCl2. Okay, let's do 1 more for calcium and oxygen. So calcium is in group 2A, so it has 2 valence electrons. Oxygen is in group 6A, so it has 6 valence electrons. So there's our Lewis dot structures. Calcium wants to get rid of 2, and oxygen needs to gain 2 to get to 8. So calcium will give both of their electrons to oxygen. So now calcium is happy because it got rid of those 2, and oxygen is happy because it gained 2. It filled in those missing spots. So calcium has a 2 plus charge because it got rid of 2 electrons. And oxygen has a full valence shell with a 2 minus charge. Okay, so if I write my formula, I have 1 calcium, Ca, with 1 oxygen, O. And even though the charges are 2 plus and 2 minus, I only have 1 ion of each one, so CaO. Now, if you notice, for all of these, if you add up the plus and the minuses, they add up to 0 every time. We have what's called a net neutral compound. So a plus and a minus is 0, plus plus 2 minus 0, 2 plus minus minus 0. And so it's a net neutral compound. So what you're going to do is continue and finish the rest of these examples on your own.